So to maximise power, it's always advisable to be disciplined and to keep the number of tests to a minimum, or at least focus on what constitutes the primary research interest that we're looking at. So now in this example, we're mainly concerned with the effects of alcohol, which are the first two simple effects. So we might limit our analyses to the first two simple effects listed. So simple effects in SPSS require the use of command syntax.
So for us to look at the simple effects, what we actually need to be doing now is a simple effect analysis, and the easiest way to do that in SPSS is to use command syntax to conduct an ANOVA simple effects analysis. So just note what we found. We found that there's a significant interaction, and now we're trying to isolate down into where that interaction is. So we're doing a simple effects analysis. So if we go to, and we're using syntax for this, and syntax is a really powerful way in SPSS to do this. Like, syntax allows you to write code, computer code, go and have a coffee, come back in a week's time, and then press the button and rerun that code. So you don't have to keep doing the same point and click over and over. So let's just go to File, New, and then Syntax. Now what we're going to do is we're going to type out the commands that are required for this. So if we go MANOVA, so MANOVA, and then it is injury, so our dependent variable, which is injury severity, by drinks, and that's got 3 levels. I'll explain this first line in a little bit. Activity 2. Okay, so what this first line of the MANOVA tells us is that we've got a dependent variable of injury severity. And what we're going to do is that we're looking at the independent variables of drinks, which has 3 levels, coded from 1 through to 3. So remember, 0 drinks was coded as 1, 2 drinks was coded as 2, and 4 drinks was coded as 3. And then we've got activity, 1 and 2. So that was coded, there's 2 levels of activity. First level of activity was coded as 1, which was low activity, and second level of activity was coded as 2, which was high activity. Then what we're going to be doing is the second line, so we put a / and then error. Now you might see this pop up in your drop down menu there, so just select it if you want, equals within. So we can see it there. And what that's essentially telling us is the second line that specifies that the error term to be used here is from the main analysis. Now the third line is specifying the type of simple effect that we want to be doing. So we go / and then you might see a bunch of drop downs, so choose design there, equals drinks within activity, within the first level of activity. So we're going to have a look at the we're going to look at drinks across low activity levels. And then we're going to look at drinks across the high activity levels. Sorry, it's just easier to do that. So what we're doing is we're narrowing down, we're basically trying to find out where that significant interaction is. Looking at firstly low activity, and also looking at doing simple effects there, and looking at high activity and doing simple effects there. So, and then full stop, and then we press the play button.
Here's the extract from the output of the simple effects. So these are results of the simple effects of drinks of alcohol with the first level of activity, which was playing the low activity Wii game. Refer back to the SPSS dataset and you'll see that this is for the low activity Wii game. So the sig value of F is greater than our Bonferroni adjusted alpha level of 0.025. Therefore, this simple effect is not significant. So this tells us that there are no significant effects of alcoholic drinks on injury severity ratings when people are playing low activity Wii games. So these are the results of the simple effect of drinks of alcohol with the second level of activity, which was playing the high activity Wii game. Again, refer back to the SPSS and you'll see that this is for the high activity Wii game. And what you can see here is that the sig value of the F is smaller than our Bonferroni adjusted alpha level of 0.025. Therefore, the simple effect is significant. So this tells us that there is a significant difference somewhere across the number of drinks concerned when people are playing high activity games on their Wii. So the simple effect of alcohol for the low activity Wii game was not significant. We will not focus on this anymore, as I now know that the alcohol relationship and injury severity rating does not occur in low activity games. However, the simple effect for alcohol for the high activity Wii game was significant. So now I'm going to focus my attention, my energy, on the alcohol relationship to injury severity in the high activity Wii game. However, there are 3 levels of drinking alcohol: 0, 2 drinks, and 4 drinks. In other words, there are 3 levels of drinking, and now we need to perform a simple effect comparison to pinpoint exactly which levels of alcohol are different from which. The easiest way to do this is with comparison coefficients. The best way is through user-specified contrasts or comparisons. Contrasts and comparisons, I'm using these terms interchangeably. So in order to continue to use the error term in the full design, the best way to do this is to convert the 6 cells of the design to a one-way ANOVA and to set up coefficients to specify the desired contrasts. By the way, it's always desirable to use the full design error term, as it's a better estimate of the population error, but only of course when you have homogeneity of variance, as we do in this case. Okay, so to talk about contrasts in this design, let's first look at the contrast we want to make and slowly build a coefficients table. Now I'm building a coefficients table because what I'm going to do is I'm going to enter these comparisons into SPSS. Now these coefficients, all they are just weights that specify which cell or cells are to be compared with which. So to work this out, a good idea is to draw up a matrix, which I'll do here. The first thing to do is to list the 6 cells of the design and their means. Then we specify our comparisons. So none of the low activity Wii games are involved. So we assign them coefficients of 0 to indicate this. We also assign zeros to all cells not involved in a specific comparison. And then we assign a 1 and a -1 to the relevant cells to indicate which ones are to be compared. And as a general rule of thumb is to assign a positive number on the one with the highest mean in the comparison. So let's step through it. I'm only interested in the high activity Wii games as that was where my simple effect was significant. So what I want to do is I want to compare 0 drinks with 2 drinks, 2 drinks with 4 drinks, and 0 drinks with 4 drinks. So if I was to draw these up in a table, you can see this in the first row. So now if I take the mean of each, which you can easily see in your descriptive table. Now the next question I want to ask is, how many comparisons am I interested in just the high activity game? Well, I'm interested in comparison 1, it's 0 drinks with 2 drinks. In comparison 2, it's 0 drinks and 4 drinks, so I assign a 1 or a -1. In comparison 3, it's 2 drinks with 4 drinks. So again, I assign a 1 or a -1. So the general rule of thumb is that the cell with the highest gets a positive value of 1. So in the first comparison, I'm comparing 0 with 2 drinks. So 2 drinks in the high activity Wii game has a higher mean than 0 drinks in the high activity Wii game. So it gets a positive 1, and the other gets a -1. We also assign zeros to all cells specified not involved in the specific comparison. So this comparison tests if 47.5 is different from 47.0. In the second comparison, I'm comparing 0 drinks with 4 drinks. So 4 drinks in the high activity Wii game, that has a higher mean than the 0 drinks in the high activity Wii game. So it gets a positive 1 and the other gets a negative 1. We also assign zeros to all other cells not involved in the specific comparison. So this comparison is just simply testing if 52.5 is significantly different from 47. And in the third comparison, I'm comparing 2 drinks with 4 drinks. 4 drinks in the high activity Wii game has a higher mean than 2 drinks in the high activity Wii game. So it gets a positive 1 and the other gets a negative 1. And we also assign zeros to all the cells not involved in this specific comparison. So this comparison is actually testing if 52.5 is significantly different from 47.5. So note that the coefficients must always sum to 0. They won't make sense otherwise. Also have a look at the planned comparisons and trend analysis in your readings, in addition to understanding orthogonal comparisons. That's the comparison, and the comparisons that we have done here, they are not orthogonal. Again, if we want to strictly maintain family-wise error, then we want to use a Bonferroni correction. If you remember, we were already using a 0.025 to do a simple effects. Now we've done a further 3 comparisons, which drops the alpha to an adjusted alpha level of 0.008, which is 0.025 divided by the number of tests we're doing, which in this case is 3.
Okay, so what we've found so far is that there is a significant interaction between type of activity of the Wii game and number of alcoholic drinks on injury severity ratings. So what we've determined so far is that we've basically looked at a simple effects, run 2 simple effects, and we found that the significant interaction does not exist in the low activity Wii game. The significant interaction exists in the high activity Wii game. Now, in the previous part of the lecture, I showed you how to construct a coefficients table. Now, that coefficients table, what that does, those coefficients allow us to enter in the correct order into SPSS. And it tells SPSS when it runs a one-way ANOVA which cells we want to compare. So we're about to use these cells that have been laying dormant here for this entire analysis. So if I go to Analyze, I'll get rid of that. We go to Analyze, we go to Compare Means, we're going to do a one-way ANOVA. Now I'm going to do a one-way ANOVA between injury severity scores and my cells. Now what I want to tell SPSS is what cells I want to compare. And as you already know, I want to compare the cells that are in the high activity Wii game. So that's going to be cell 2, it's going to be cell 4, and it's going to be cell 6. And we already drew up the coefficients table, so I'm about to show you how we enter in that coefficients table to tell SPSS which cells we want to compare. So let's click on contrast. Now, let's look at the first comparison in your coefficients table that I explained previously. You can see that it's 0, -1, 0, 1, 0, 0. So I'm about to enter that into this contrast. So if I go 0, add, then -1, add, and then 0, add, and then I think it's 1, add, and 0, add, 0, add. So that -1 is for cell 2. That's comparing that cell 2, which is a high activity game with no alcoholic drinks under your belt. So it's comparing those injury severity ratings for that cell compared to cell 4, which is high activity games, Wii games, with 2 drinks under your belt. So it's comparing those injury severity scores. So the first comparison is comparing cell 4 to cell 2. And then we go next. Now the second comparison, so that was 0. If you look at your coefficients table, it was 0, -1, 0, 0, 0, 1. So let's enter that in. So that goes 0, -1, 0, 0, 0, and 1. So what that's essentially saying is cell 2, I'm going to compare cell 2 to cell 6, and all the ones with 0, so that's cell 1, cell 3, cell 4, and cell 5. I'm not going to compare it all. So if I come back to this, this data here, I'm going to compare cell 2, so those who had high activity Wii games with no alcoholic drinks under their belt, to cell 6, those who played high activity Wii games with 4 drinks under their belt. Press next. Now I'm on to comparison 3 of 3, or contrast 3 of 3, so comparison 3. So if you'll have a look at your coefficients table, you can see that's coded as 0, 0, 0, negative 1, 0, 1. So I won't go into explanations of why. Hopefully you understand, you've got that now. Why this is 0 and why this one's negative 1 and 0 and 1. So what that's essentially saying is that cell 6 I'm going to compare to cell 4. So in other words, high activity Wii games with 4 drinks under your belt. So with that injury severity rating, I'm going to compare it to cell 4. So high activity Wii game with 2 drinks under your belt. And why it's getting 1 is because that has a higher mean. Cell 6 has a higher mean than cell 4. Okay, which gets negative 1. Press continue. Sorry. Let's go next. Now press continue. And then press OK.
So we know from the beginning that we can assume equal variances. So we use the results from the top table. 2 of the comparisons are less than the Bonferroni adjusted alpha of 0.08 or 0.008. So from contrast 1, I conclude that there's no significant difference in injury severity ratings for high activity Wii games across the 0 and 2 drinks condition. From contrast 2, I conclude that the mean injury rate on high activity games on the Wii for people who drink 4 drinks is significantly higher than for those who drink 0 drinks. And from contrast 3, we conclude that the mean injury severity rating for the high activity Wii game for people who drink 4 drinks is significantly higher than those who drink 2 drinks. So note that in the complex designs with many tests, the researcher may decide to use a more liberal family-wise alpha, perhaps 0.10 or even 0.15. But again, the decision must be made beforehand, not after you've seen the results. As the saying goes, you can't buy your lottery ticket after you know the winning numbers. So, well, it's the same here. You can't make decisions to adjust your alpha based on your results after you've done the results. The decision has to be made before the analysis. So you can see that there's this significant interaction in the graph provided here. On the green line, there's a significant difference in injury severity rating between 4 drinks and 2 drinks, and a significant difference in injury severity ratings between 4 drinks and 0 drinks. So please look at your readings for how you may write up between subjects factorial and ANOVA when there is an interaction using APA format. Thank you.